Deep beneath the Earth's surface, ancient secrets lie waiting to be uncovered. Millions of years ago, our planet was the domain of colossal creatures that ruled with unmatched power and majestic beauty. This was the age of the dinosaurs, lords of the land, who dominated the world for more than 165 million years, from the Triassic period to the end of the Cretaceous period. Today, we embark on a journey into that lost world, where life exploded in countless bizarre forms, from ferocious predators to massive herbivores. Fossils unearthed from ocean depths to mountain peaks reveal a tale of mystery and drama, where survival was a constant battle and life and death intertwined in an endless struggle. Let us start at the beginning. The dinosaur era dawned around 230 million years ago, during the Triassic period, as the Earth recovered from a massive extinction event. At that time, the single supercontinent Pangaea began to split apart, forming new lands with warm climates, lush forests, and vast rivers and lakes. Dinosaurs emerged as an evolved group of reptiles, with straight legs that allowed them to move more agilely than their ancestors. They were not monsters from the start. Many early species were no larger than a turkey, but over time, they grew into gigantic beings, diverse in shape and size. From agile two-legged carnivores to enormous four-legged plant eaters, dinosaurs adapted perfectly to their surroundings, claiming every corner of the planet. This was an era of rapid evolution, building a rich ecosystem where roars echoed through primeval forests and heavy footsteps shook the ground. The Triassic marked a pivotal shift in Earth's history. Following the Permian-Triassic extinction, which wiped out nearly 96% of marine species and 70% of terrestrial vertebrates, the stage was set for new life forms to thrive. Dinosaurs, along with other archosaurs like pterosaurs and crocodilians, filled the ecological niches left vacant. Their upright posture gave them a biomechanical advantage, enabling faster locomotion and better energy efficiency compared to the sprawling gait of earlier reptiles. Paleontologists have pieced together this story from fossil beds around the world, such as those in Argentina's Isigualasto Formation, where early dinosaurs like Eoraptor and Herrerasaurus reveal slender bodies and sharp teeth, hinting at their predatory origins. These creatures measured about 3 to 6 feet long, weighing as little as 20 pounds. Yet they laid the foundation for the giants to come. As Pangaea fractured into Laurasia in the north and Gondwana in the south, shifting continents influenced global climates and habitats. Warm, humid conditions fostered dense vegetation, including ferns, cycads, and conifers, providing ample food for emerging herbivores. Meanwhile, carnivorous dinosaurs honed their hunting skills in this dynamic environment. By the late Triassic, species like Coelophysis, found in the Ghost Ranch quarry in New Mexico, showcased pack behavior, with fossils of multiple individuals suggesting they lived and hunted in groups. This social structure likely improved their success in taking down prey, a trait that would persist in later dinosaurs. Transitioning into the Jurassic period around 201 million years ago, dinosaurs truly came into their own. The breakup of Pangaea accelerated, creating shallower seas and more varied landscapes. This period saw the rise of sauropods, the longest and heaviest land animals ever, but our focus turns to the predators that kept the balance. The Jurassic forests and floodplains teemed with life, from small mammals scurrying underfoot to flying reptiles soaring overhead. Dinosaurs diversified rapidly, with theropods, two-legged meat-eaters, developing keen senses and powerful limbs. Allosaurus, a prominent Jurassic predator from North America, grew to about 30 feet long and weighed up to 2 tons, using its serrated teeth to slash at victims like the armored Stegosaurus. Yet, it is in the Cretaceous period, from 145 to 66 million years ago, that dinosaurs reached their peak diversity. Continents drifted further apart, leading to isolated populations and unique adaptations. In what is now North America, vast inland seas divided the land into eastern and western regions, fostering distinct ecosystems. Floodplains, swamps, and coastal plains supported a bounty of plant life, from flowering plants that first appeared in this era to towering redwood-like trees. Herbivores grazed in herds, while predators lurked in the shadows, maintaining the delicate equilibrium of nature. Now, let us delve into some of the most iconic dinosaurs, starting with the apex predators that embodied raw power and cunning. Foremost among them is Tyrannosaurus rex, often called T-Rex, the king of the tyrant lizards. This beast roamed North America during the late Cretaceous, about 68 million years ago, in landscapes of broad plains crisscrossed by rivers and dotted with low-lying forests. Measuring up to 40 feet in length and weighing over 7 tons, T-Rex was a perfect killing machine. Its massive head housed jaws lined with banana-sized teeth, each up to 12 inches long, capable of exerting a bite force 3 times that of a great white shark, enough to crush bone and tear through flesh with ease. Fossils from sites like Hell Creek Formation in Montana provide vivid insights into T-Rex's life.
One specimen, nicknamed Sioux, discovered in South Dakota, is one of the most complete skeletons ever found.
One specimen, nicknamed Sioux, discovered in South Dakota, is one of the most complete skeletons ever found, revealing a creature that stood about 13 feet tall at the hip. Despite its short forelimbs, each only about 3 feet long, with 2 clawed fingers, T-Rex compensated with extraordinary senses. Its forward-facing eyes granted binocular vision for depth perception, ideal for tracking prey, while an enlarged olfactory bulb in the brain suggests a keen sense of smell, allowing it to detect carrion or injured animals from miles away. Contrary to early depictions as a sluggish brute, biomechanical studies indicate T-Rex could reach speeds of up to 25 miles per hour in short bursts, though it was not built for long pursuits. In its habitat, T-Rex navigated a world teeming with potential meals. The western interior seaway split North America, creating humid, subtropical conditions in the west, where ferns and angiosperms flourished. Herds of duck-billed hadrosaurs and horned ceratopsians roamed these areas, providing ample targets. Evidence from bite marks on fossil bones shows T-Rex often ambushed these herbivores, using its powerful neck muscles to deliver devastating bites. Scientists debate whether T-Rex hunted in packs. Some fossils show multiple individuals at death sites, suggesting possible family groups or opportunistic gatherings around kills. Additionally, isotopic analysis of teeth indicates a varied diet, including scavenging, proving its adaptability in a competitive environment where food could be scarce during dry seasons. The roar of a T-Rex would have been a bone-chilling sound, reconstructed through computer models based on related species like birds and crocodiles. Low-frequency infrasound could travel far, intimidating rivals or coordinating with kin. Juvenile T-Rex, slimmer and faster, likely targeted smaller prey, growing rapidly to adult size in about 20 years. Pathologies in fossils, such as healed fractures and infections, attest to a rough life filled with battles, perhaps territorial disputes or clashes with other predators like the slightly smaller Albertosaurus. This diversity among predators highlights the intricate web of life in the dinosaur world. While T-Rex reigned supreme in its domain, other carnivores filled different roles, from swift pack hunters to stealthy ambushers. Each adapted to specific niches, ensuring no single species overwhelmed the ecosystem. As we continue our exploration, we turn to the formidable herbivores that countered these threats with armor and numbers, and the clever smaller predators that relied on speed and strategy rather than sheer size. The balance between predator and prey drove evolution, leading to innovations like enhanced senses, protective features, and social behaviors. In the lush valleys and arid badlands of the Cretaceous, life pulsed with energy, each day a testament to resilience. Fossils continue to yield clues, with advanced techniques like CT scanning revealing internal structures, from brain cavities to muscle attachments, painting a fuller picture of these ancient rulers. Among the herbivores that stood as bulwarks against such formidable hunters was Triceratops, one of the most renowned plant eaters, evoking the image of an ancient warrior clad in natural armor. This dinosaur inhabited the same late Cretaceous landscapes as T. rex, roughly 68 to 66 million years ago, across the open grasslands and shrublands of North America. With a body stretching up to 30 feet long and weighing between 6 and 12 tons, Triceratops was a behemoth built for defense. Its most striking features were the three sharp horns adorning its skull, two long ones above the eyes, each reaching over 3 feet, and a shorter one on the nose, paired with a massive bony frill that shielded its neck like a medieval shield. Paleontologists have uncovered Triceratops fossils in abundance from formations like Lance and Hell Creek, where dozens of skeletons reveal a life of constant vigilance. These creatures roamed in herds across vast floodplains, where seasonal rivers nourished ferns, horsetails, and early flowering plants. Their low-slung heads, equipped with a beak-like mouth and rows of shearing teeth, were perfect for cropping tough vegetation close to the ground. The frill, once thought purely decorative, now appears multifunctional through biomechanical analysis. It anchored powerful jaw muscles for grinding food, and served as a display for mating rituals, with blood vessels suggesting vivid colors and life. In the face of predators, Triceratops relied on collective strength and physical prowess. Fossil evidence shows healed puncture wounds on frills and horns, matching T. rex tooth marks, indicating fierce confrontations where a charging Triceratops could impale an attacker with devastating force. Computer simulations estimate that an adult could generate over 10,000 pounds of impact energy in a head-on ram, enough to flip a smaller foe. Yet, these battles were not always solitary. Herding behavior, inferred from mass bone beds containing multiple individuals of varying ages, suggests safety in numbers. Juveniles, more vulnerable with softer horns, likely stayed protected in the center, while adults formed a defensive perimeter, horns outward, much like modern musk oxen. This interplay underscored the Cretaceous ecosystem's equilibrium, where herbivores evolved countermeasures to match predatory threats. Triceratops' robust limbs supported its weight on swampy terrain, and its keen eyesight, evident from large eye sockets, helped spot danger amid the misty mornings of prehistoric deltas. Beyond defense, the horns played roles in intraspecies rivalries. Scarred skulls point to jousting matches over territory or mates, where males locked horns in displays of dominance, echoing the rutting behaviors of contemporary deer or rhinos. Shifting our gaze to smaller yet no less lethal carnivores, Velociraptor emerges as a master of agility and intellect in the dinosaur realm. Thriving in Asia around 75 to 71 million years ago, this dinosaur was compact, standing about 1.5 feet tall at the hip and extending 6 feet from nose to tail, with a weight of roughly 40 pounds. Fossils from the Jade-Okta Formation in Mongolia's Gobi Desert paint a picture of arid dunes and sparse oases, where dust storms whipped across barren plains, and survival demanded cunning over brute force. Velociraptor's arsenal included a sickle-shaped claw on each hind foot, up to 3 inches long, curved like a scimitar for slashing vital arteries. But its true edge lay in pack dynamics. Discoveries of multiple specimens at kill sites imply coordinated hunts, where groups of 5 or more flanked larger prey, like Protoceratops, leaping to deliver precise strikes to the throat or underbelly. Brain scans via CT imaging reveal an enlarged cerebrum relative to body size, suggesting advanced problem-solving and communication, perhaps through vocalizations or visual signals, precursors to avian calls. Intriguingly, feather-like structures preserved in related species, and even some velociraptor fossils, indicate proto-feathers for insulation in the desert's temperature swings, forging a direct link to modern birds. This feathering may have aided in display or even limited gliding, enhancing ambush tactics in rocky outcrops. Stable isotope studies of teeth show a diet of small mammals, lizards, and occasional larger herbivores. with evidence of cannibalism during lean times, highlighting opportunistic feeding in a harsh, resource-scarce environment. Velociraptor's speed, estimated at up to 40 miles per hour in bursts, allowed it to outmaneuver foes, while its lightweight build and flexible tail provided balance during chases across uneven sands. These adaptations exemplify how smaller dinosaurs carved niches amid giants, relying on strategy and synergy. In the flickering shadows of Cretaceous campfires, if such existed in our imaginings, these packs would have been the stuff of nightmares, their hisses and claws a symphony of precision predation. Yet, this vibrant tapestry of life unraveled abruptly around 66 million years ago in one of Earth's most cataclysmic events. The primary culprit, a colossal asteroid, roughly 6 miles wide, slamming into the Yucatan Peninsula, forming the Chicxulub crater that spans over 90 miles today. This impact unleashed energy equivalent to billions of atomic bombs, vaporizing rock and igniting global firestorms that scorched forests across continents. Tsunamis hundreds of feet high ravaged coastlines, while ejected debris blanketed the atmosphere, blocking sunlight for months or years. Compounding the disaster were massive volcanic eruptions from the Deccan Traps in India, spewing lava over hundreds of thousands of square miles and releasing toxic gases like sulfur dioxide, which acidified oceans and altered climates. The combined assault triggered a cascade of failures. Photosynthesis halted, plunging temperatures in a nuclear winter-like scenario. Food chains collapsed as plants withered, starving herbivores and, in turn, carnivores. Acid rain poisoned water sources, and seismic shocks triggered landslides and earthquakes far from the impact site. Fossil records from the KPG boundary, a thin clay layer rich in iridium, an element rare on Earth but common in asteroids, mark this tipping point, with a stark drop in diversity above it. Non-avian dinosaurs, pterosaurs, and many marine reptiles vanished, while survivors included small, burrowing mammals, crocodilians, and avian dinosaurs, the ancestors of birds who could scavenge seeds or insects in the dim aftermath. This mass extinction, claiming about 75% of species, paved the way for mammalian dominance, including our own lineage. From these ashes, lessons endure. Modern paleontology employs DNA sequencing from collagen in well-preserved bones, isotopic dating for precise timelines, and 3D modeling to simulate behaviors, from gait analysis to bite mechanics. Ground-penetrating radar uncovers new sites, while citizen science apps crowdsource fossil finds, expanding our knowledge base. These insights inform contemporary issues. Understanding past climate shifts helps model current warming trends, where rising seas and biodiversity loss echo ancient perils. In marine realms, plesiosaurs and mosasaurs patrolled depths, but on land, the dinosaur saga reminds us of life's fragility and tenacity. As satellites map potential asteroid threats and conservation efforts safeguard endangered species, we honor these prehistoric titans. Their legacy, etched in stone, urges stewardship of our planet, ensuring that evolution's next chapter favors resilience over ruin. And so, the exploration persists, bridging eons to illuminate our shared history on this ever-changing world.